Hello friends, today we are going to solve some of the problems which are expected in GATE 2026 examination. So few important problems uh, related to consolidation of soil mass. Here, as you can see, this is the one of the problem that carries a lot of weight is here. Uh, the data from the lab consolidation test is given to you. The effective stress in kilopascal is given. So on the sample, uh, undisturbed sample, you have got the data of stress range from 0 to 800, and then it has been made 0. And the thickness of the sample is also given. So the thickness of the sample is in millimeter and the effective stress is in kilopascal. So at 0, the thickness of the sample is 19.70 millimeter and the pressure is increased over the sample, which is fully saturated clay sample, to 400, and therefore there is going to be reduction in the sample thickness and it becomes 18.56. Then again, the pressure has been increased from 400 to 800, thereby the thickness of the sample becomes 18.36 millimeter, and then it is completely unloaded. So the stress becomes 0 and there is going to be little increase in the sample thickness from 8.36 it becomes 18.36, it becomes 18.9 millimeter. And at the end of the experiment, the water content is found to be 28%. And the specific gravity of the soil solids is also 2.72. So we need to calculate the void ratio at the end of each stress range. So what is the stress range? 0 to 400, 400 to 800, and 800 to 0. Also calculate the coefficient of compressibility, coefficient of volume compressibility for the stress range of 0 to 400 kilopascal. And if at the side the thickness of the clay soil is 4 meter, calculate the consolidation settlement for the stress range 0 to 400 kilopascal. So that's the whole problem. So this problem needs to be solved. Now here you can just see that water content is given to you at the end of the test. So if you go to the solution, what is known to us is E into SR is the water content at the end of the experiment, that is the final water content, into GS. So this becomes the final void ratio. So EF into SR. Now because the sample is fully saturated clay, the value of SR becomes 1, and therefore the value of final void ratio you can calculate as 0.28 multiplied by 2.72. So you can multiply it and get the result very easily, uh, and the value you can find out is the final void ratio. So this becomes 0.762. This is the final void ratio that you get it, EF, at uh, at the end of the experiment. So at the end, when it is completely unloaded, so that becomes the final void ratio. So final void ratio is here at the end of the experiment. So EF you have been able to calculate. Once you know EF, you can go in the upward direction and you can find out the value of delta E, and delta E you can calculate very easily because you know that the relationship, the change in void ratio divided by 1 plus EF, and change in the void ratio is the change in thickness. So you can write it, the change in thickness of the sample. So the height of the sample is going under change, and this becomes the final void ratio. Because it is EF, this becomes HF. So that's the relationship. Delta E divided by 1 plus EF must be equal to delta H upon HF. This implies that delta E, this implies that change in void ratio. So the method is going to be change in void ratio method is going to be change in thickness of the sample, which is which you can find out, divided by the final thickness of the sample into 1 plus EF. So this formula will give you change in void ratio. Therefore, use change in void ratio method to calculate the void ratio, to calculate E at different stress range. So it's quite simple. In a tabular form, we can do it. So if you want to do it in a tabular form, you must calculate the value of delta E, and also you should be. So if you see the range over here from 800 to 0, so for stress range 800 kilopascal, this one, to 0, delta E can be found out. So delta E you can easily find it out by having the expression with you. So delta E becomes, from expression 1, what is the change in thickness? So change in thickness is going to be 18.90 minus 18.36, and what is the final height? Final height is going to be this one. So 18.90 multiplied by 1 plus EF. EF you have already calculated. So it becomes 1.76. Therefore, friends, you can easily calculate the value of delta E, and if you calculate the value of delta E, then your calculations becomes quite simpler. So because the sample is going to expand, we can calculate it. So this delta E, you can find out 18.9 minus 18.36 equal to multiplied by 1.762 divided by 18.90. So it gives you delta E equal to, because it is going to expand, swell. So it is going to be positive, and this becomes the change in void ratio is going to be equal to 0.050. 503 to be very precise, we will take it 0.050. Therefore, E at 800 kilopascal can be found out. So, what is the void ratio? Therefore, void ratio E, calculate the void ratio at the end of each pressure range. So, the void ratio, the final void ratio is already known to us. This is at the end. And at 800, void ratio E at 800 kPa can be now calculated quite easily, because we know what is the change in void ratio. Therefore, the final void ratio minus delta E can be computed. So this becomes E at 800 kilopascal is going to be, change in void ratio will become the EF value, and EF is already known to you, that is 0.762, and minus delta E is going to be plus 0.05. So this gives you 0.712. So the answer at 800, what you get it is 0.712. So E at 800 kilopascal is going to be 0.712. So friends, it is going to be quite simple if you get it in the tabular form. So in the tabular form, how will you show it? So whole calculations here you have with you, and therefore the things can be substituted in a tabular form. So let us put it for so first of all is going to be your effective pressure. So what is the effective pressure? We know the effective pressure is going to be in kilopascal. 0, then you are going to have 400, then you are going to have 800, and then again you allow it to be 0. So that is the value of this. So what is delta sigma prime? So for the pressure range, delta sigma prime, you can calculate it in kilopascal. So delta sigma prime 0 to 400, this becomes 400. So delta sigma prime becomes 400. 400 to 800, this becomes this much, and 800 to 0, that becomes the pressure range. So delta sigma prime, once you know it, then you can write the thickness of the sample, which is going to be in millimeter. So what is the thickness at 0? 19.70. So 19.70, then followed by 18.56, then 18.36, and the last one is 18.90. So this is the final HF, final height at the end of the experiment, and therefore H is known to you. Now you can easily calculate delta H. So delta H you can calculate. That is going to be again in millimeter. So difference of these two you can just calculate and find out 19.70 minus 18.56. So 18, 1, 19. So minus 1 point. It is going to decrease minus 1.14. So that's the difference. Then it becomes from 18.56 to 18.36. So minus 0.20 millimeter. And then it swells from 18.36 to 18.90. So it becomes plus because it swells. So it becomes 0.54. So delta H also you know it, because in the expression what you need is delta H. You need HF and you know EF. Then only you can find out delta E. We have written the formula that delta E equal to delta H divided by HF into 1 plus EF. So EF is known to us. EF equal to W into G, and therefore we got it as 0.762. So delta E can be found out because EF is known to you. Delta H you have just calculated. HF you know it. This is the value of HF, and therefore you can calculate the value of delta E. So let's calculate the value of delta E. So delta E, we have to go from, because it is chain in void ratio method, what you know it is EF. So friends, you know that delta E can be calculated. So delta E is going to be plus 0. Is going to be plus 0.050 is going to be 0.0. What is the expression for delta E? That we have already written, that delta E is calculated delta E divided by 1 plus EF equal to delta H divided by HF into 1 plus EF. Now this is known, delta H is known, so HF is known. So delta H here is 0.54, HF is 18.9, and EF is 0.762, and therefore delta E comes out to be 0.050. So very simple calculations you have now, and therefore I know the value of E. E equal to WF into G. So that is 0.762 at 800. At uh, the 800, the value of E at 800 is going to be 0.712 because 0.762 minus this 0.50 gives you 0.712. So this becomes 0.712. So how you can calculate the void ratio at the end of each pressure range is quite simple now. So this becomes this. And then you can also calculate the value at similarly at 400. So at 400 to 800, that can be also calculated. For this pressure range, you are going to calculate like this. So first pressure range we have been able to calculate, and for pressure range 400 to 800 kilopascal. So if you go to this pressure range, delta E you can calculate. So delta E, how will you calculate it? What is the formula for delta E? That you know it. So delta E equal to minus delta H upon the value of final void ratio. So at 400, what is the value of final? That is 18.36. So 400 to 800, 18.36. So 18.36 is HF into, you can take it 1 plus EF. And now at here 1.712 because EF is a 400 to 800, this pressure range, this is the value of EF. So delta E you can easily calculate for the pressure range of 400 to 800, and that comes out to be minus 0.019. So this comes out to be minus 0.019. So friend, delta is known to us. So this becomes 0.019, and this is negative. This is positive. So delta E has been calculated. Similarly, you can calculate it to for other pressure range. Other pressure range is going to be 0 to 400 kilopascal. So for pressure range of 0 to 400 kPa. So now we are going to take this range, calculate in the similar fashion the value of delta E. So delta E for that pressure range is going to be minus 1.14. This value delta H minus 1.14 divided by 18.56, right? So you are going to get this value for this one into 1 point. Now E at 400 you have to find it out. So how will you find out the value? Delta E is known to you. So delta E is here and the value of E is known to you, and therefore if you deduct this value, so 0.712 minus and minus of 0.019 0.019. So how will you calculate this? At this particular value, the value of E will be 0.712 plus this, so it becomes 0.731. So E minus delta E will give you 0.731. So this can be also calculated. So the friends, the value of this is going to be 1.731, and therefore you get the new value of delta E, and that is going to be minus 0.106. So it becomes 0.106, and it is negative. Only positive is here where it swells. So now in the similar fashion, I can calculate the another value, and another value will be 0.731 plus 0.106, and therefore it becomes 0. This minus this is minus minus plus, so it becomes 0.7 and 1, it becomes 837. So you can find out for this pressure range also. So friends, you can find out now AV. So AV you can find out for 0 to 400 delta E. What is AV? It is called the volume of compressibility, which is going to be delta E upon delta sigma prime. So delta E is going to be difference of these two, that is 0.837 minus 0.731, that is 0.106 divided by, it is from 0 to 400, so divided by 400 kilopascal delta sigma prime. So it becomes quite simple. You can calculate this and get the value of AV. So what is the value of AV that we can calculate and show it to you? So if we calculate 0.106 divided by 400, 2.65 into 10 raised to minus 4, and its unit will be meter square per kilonewton. So I am getting for this pressure range 0 to 400, this pressure range, the value of AV I am getting as 2.65 into 10 raised to minus 4. Similarly, you can find out the value of MV. MV equal to AV divided by 1 plus E naught. So this also you can find it out. This becomes 1.1837. E naught is already known to you at 0, and therefore it gives you divided by, so it gives you 1.44 into 10 raised to minus 4. And its unit will be also meter square per kilonewton. So you have been able to calculate AV, you have been able to calculate MV also. So AV and MV can be calculated for the stress range of 0 to 400. So this problem can be easily attempted by change in void ratio method. The method is known as change in void ratio. method. So you have to go in the tabular form from down in the upward direction and find out the void ratio. Once you are able to find out the void ratio, then things follows. Now, up to here, it is all over. We have been able to calculate. Now, let's go to the next part. Now, what is given? If at the site of the thickness of the clay soil is given to you. What is the thickness? So, friends, at the site, the thickness of the clay is given to you as 4 meter, and the pressure range is going to be delta sigma prime is going to be 400 kilopascal. So you need to calculate the consolidation settlement. Calculate the consolidation settlement. So how will you calculate this consolidation settlement SC? SC, as you know, can be calculated from the linear expression that SC equal to mv into delta sigma prime into H naught. So here mv is already calculated. We have shown the calculation. So 1.44 into 10 raised to minus 4, 1.44 10 raised to minus 4 meter square per kilonewton. Delta sigma prime is going to be 400 kilopascal, and H naught is going to be, this is the height, 4 meter. So finally you will be getting the calculation in terms of meter. So you can all calculate this. 1.44 10 raised to minus 4 multiplied by this is the answer of this part. So we have been able to calculate void ratio. Also, we have been able to calculate AV and MV, and then we have been able to predict the consolidation settlement if the pressure range is going to be delta sigma prime is going to be 400 kilopascal. So for this pressure range, this can be done. So this is one of the important problem that can be asked in the examination, and you should be prepared to answer this. So next problem we will be taking all expected problems, important problems. I am going to do it, and if you have any problem in your mind, do post it. I will solve it in my coming videos. This is the 10th video for gate preparation. So friends, now what is next is another important expected problems. So this is the second problem that I would like to take. Now in this problem, we have got the sample from the site. So there is the site. There is going to be clay soil. And the sample has been collected. The height of the sample is 4 meter. And then in the laboratory, we have collected the UDS, undisturbed sample, and we have carried out lab consolidation test. and all the data that we got from the consolidation test is the initial void ratio, which is 0.8. So initial void ratio is known to you, and the pre-consolidation pressure, pre-consolidation pressure or stress, that is called sigma C prime, is given to you here. Pre-consolidation pressure has been found out to be 140 kilopascals. So the pre-consolidation pressure, you can easily find it out if you have got all the lab data. So this is given to you, that and liquidity of the given soil, clay soil, is given to you 40%. That means it is clay with intermediate plasticity, CI soil. So this is 40%, and the ratio of compression index CC upon recompression index CR is CC upon CR is also known to you as 9. So these values are given, and we have to calculate the consolidation settlement, that is SC, if the present overburden pressure. Calculate consolidation settlement if the present overburden pressure is 80 kilopascal. The present overburden pressure is 80 kilopascal. So, and the increase in average pressure and increase in average stress is also given to us, 100 kilopascal. So pre-consolidation pressure is given to you. You have been given the present overburden pressure. You have been also given the average increase in pressure, that is 100 kilopascal, and the thickness of the CI soil at the site is 4 meter. So the thickness of CI soil at the site equal to 4 meter. So friends, how to solve this problem? So looks quite simple, because if you want to calculate the consolidation settlement, you must know the pre-consolidation pressure, and the pre-consolidation pressure is already given to you. It is 100 kilopascal, and the present pressure overburden is 80. So you let us look the solution. So overburden pressure present is 80 kPa, and the increase in pressure due to any external loading, the increase in average stress is 100. So delta sigma prime is 100 kPa. So what is the total pressure? So total pressure sigma naught prime plus delta sigma prime becomes 180 kilopascal. So on this particular layer, this sigma naught prime plus delta sigma prime is going. Now what is the pre-consolidation pressure? Now pre-consolidation pressure is uh, here 140 kilopascal. So sigma naught prime plus delta sigma prime is greater than the pre-consolidation pressure, which is 140. Now liquid limit is this is 140 kilopascal. Now liquid limit is given to you as 40%. Therefore, you can calculate the compression index Cc. You know that compression index Cc is going to be Tarjagian-Peck formula is quite popular. For UDS, it is going to be 0.009 liquid limit minus 10. So it becomes 40 minus 10, that is 30. So it becomes 0.27. So Cc value is known to us. Now, next, if you see, the ratio is also given, Cc upon Cr. So Cc upon Cr is 9. Therefore, Cr equal to Cc divided by 9. So this recompression index becomes 0.27 divided by 9, and therefore it becomes 0.03. So now we have got Cc, we have got Cr, and therefore consolidation settlement is going to be now a very simple way we can calculate it. Cr into H naught divided by 1 plus E naught into log of sigma C prime which is higher now. Sigma C prime is 140 kilopascal. This is 140 kilopascal. And sigma C prime divided by sigma naught prime. And what is sigma naught prime? The sigma naught prime value is given to you, the present overburden pressure. This is called sigma naught prime. So present overburden pressure is given to you as a T, and sigma C prime is the pre-consolidation pressure, which is given as 140. So this becomes the formula, log of sigma C prime divided by sigma naught prime plus, for normally consolidated soil, you should always use Cc, that is the compression index. So it becomes Cc into H naught divided by 1 plus E naught into log of, now it has to higher pressure upon lower pressure. Now the higher pressure is sigma naught prime plus delta sigma prime divided by sigma C prime, pre-consolidation pressure. So this becomes the formula, and once this becomes the formula, you can take the stress range for the first term. It will be 140 by 80, So it becomes 140 by 80. So you can calculate this. The value of H naught is already known to you because the thickness is already known to you, that is 4 meter. And E naught is 0.8. So H naught by 1 plus E naught, you can take it out. CR is going to be 0.03. We have calculated it, and into log of sigma C prime, that is pre-consolidation pressure, divided by present overburden pressure. Cc is already known to us. This we have taken it out. So H naught upon this multiplied by log of, this is going to be from the pressure range, which is going to be from sigma C prime, which is 140, up to the maximum pressure is 180 to the base 10. So if you simplify, you will be getting the value of SC, and this comes out to be 0.081 meter. That is 81 millimeter. So friends, you can see how this problem can be solved. What is the range of uh, over consolidated soil or pre-consolidated soil? And then for normally consolidated NC soil mass, you can sum it up and find out the final value of SC consolidation. So this is how the important problems can be solved. I will continue all the expected problems, tougher problems, so that I can explain you conceptually and solve it like this. So in the next video, you can expect a few important problems. Thank you very much.